Hello there! In this lesson, we will look at measures of dispersion, which help paint a more comprehensive picture of data. Let's get into it. In the pre-video activity, you took on the role of a head basketball coach who was forced to pick the best free throw player to try and clinch the state title. If you haven't completed the activity, pause and do that now. As your calculations show, all three players have an overall average of 67% from the free throw line. So is there a best choice? Or can you pick any of the three? In this video, we're going to expand our understanding of the data using new statistical values called measures of dispersion. A measure of dispersion is a statistical tool used to describe the spread or variability of a dataset. It indicates how much the data points differ from the central value, such as the mean or median. In other words, it helps us understand whether the values in a dataset are closely clustered around a central value or widely spread out. Common measures of dispersion include range, interquartile range, and standard deviation. By the end of this lesson, you'll see how these measures help us understand the consistency and variability of a dataset. As an advanced math student, you have a lot of experience with range. The range of a function describes the output values of the function from the smallest to the largest. Range works in a similar way with data. The range of a data set is the difference between the highest and lowest values. Look at the free throw percentages for player 1. The lowest percentage in 10 games was 56%, and the highest was 78%. So, we'll take 78 minus 56 to find this player's free throw percentage range is equal to 22%. Pause the video and calculate the range of players 2 and 3. Player 2's lowest percentage was 56% and their highest percentage was 80%, which means their range is 24%. Player 3's lowest percentage was 17% and their highest percentage was 100% for a range of 83%. What do the range values tell you about each player? A low range, like with player 1, tells us the data points are close to each other. In other words, there is low variability within the data. On the other hand, a high range, like with player 3, indicates more spread in the data points and higher variability. Let's take a look at another measure of dispersion. The interquartile range of a dataset, also called IQR, describes the range of the middle 50% of a dataset and is calculated by taking the difference between Q3 and Q1. Do those values sound familiar? We worked with the first and third quartiles when finding the 5-number summary to create a box and whisker plot. You can see here, the interquartile range is actually represented by the box of the box and whisker plot. When the IQR is small, it indicates that the middle 50% of the data is closely concentrated around the median. When the IQR is large, it indicates that the middle 50% is more spread out from the median. When you're given raw data, you'll have to determine the first and third quartiles of the data before you can calculate the IQR. Do you remember how to find those values? Start by finding the median of the overall dataset. Now you can find the first quartile, the median of the lower half of the data, and the third quartile, the median of the upper half of the data. In the pre-video activity, you already identified the median percent for each of the 3 players. Pause the video and use those values to find Q1, Q3, and the interquartile range for each of the 3 players. Then, use the values to create a box plot for each of the 3 players on the number lines in your guided notes. Here are the box plots for each player. Do your plots look like these? For player 1, the first quartile value is 60%, and the third quartile is 75%, which means their IQR is equal to 15%. Player 2's first quartile is equal to 56%. The third quartile is 78%, which means their IQR is equal to 22%. Finally, player 3's first quartile is equal to 38%. The third quartile is 91%, which means their IQR is equal to 53%. How do you interpret the IQR values for each of these players? Player 1 has the lowest IQR at 15%. This tells us that the middle 50% of their data is relatively close together, which we can see on the box plot, indicating more consistency in the data. On the other hand, player 3 has the largest IQR at 53%, indicating that the middle 50% of their data is widely spread out and inconsistent. Let's take a look at the last measure of dispersion before we make any final decisions about who we're sending to the line. The final measure of dispersion we'll examine today is the standard deviation. The standard deviation is the average distance between each data point and the mean of the data. It can tell you how spread out or clustered the data is around the average. To calculate the standard deviation of a dataset, we'll use the following steps. Step 1. Calculate the mean of the dataset. Step 2. Subtract the mean from each data point. Step 3. Square each value you calculated in Step 2. Step 4. Find the average of the values from Step 3. Step 5. Take the square root of the average from Step 4. Standard deviation is reported in the same units as the data, so in our case, we'll express standard deviation as a percentage. Let's calculate the standard deviation for player 1 together. You've already calculated the mean for player 1. It's equal to 67%. Next, we'll subtract 67 from each data point for all 10 games. Step 3 says to take each value from Step 2 and square it. Next, we'll calculate the mean of the squared deviations by taking the sum and dividing by 10. And finally, we'll take the square root of the mean from Step 4 to find the standard deviation for player 1, which is equal to 7.3%. Before we investigate what this means, pause the video and calculate the standard deviations for players 2 and 3. Player 2 has a standard deviation equal to 9.2%. And player 3 has a standard deviation of 26.8%. So, we can calculate the standard deviation, but what do we do with it? Great question. Remember, standard deviation tells us how concentrated our data values are around the mean. A lower standard deviation, like with player 1, indicates that values are closely clustered around the mean. A high standard deviation, like with player 3, tells us that values are more spread out from the mean. When comparing data sets, as we are doing here, a smaller standard deviation will represent less variability versus a data set with a higher standard deviation, which will have higher variability. So, time is ticking. We need to decide which player we are sending to the line. Pause the video now to consider the measures of dispersion for each player and take your pick for which player will give your team the best chance at the state title. Then come back to discuss. Let's start by eliminating the weakest option. Which player do you think gives the team the least likely chance of winning based on these statistics? Did you say player 3? If so, I agree. Player 3 has the largest range by a significant margin, meaning that although their average is the same as that of the other two players, there were likely some games where their free throw percentage was quite low, which we can indeed see in the data. The values for IQR and standard deviation are also quite a bit higher than those of the other two players, showing a high variability in this player's free throw percentage. If we're choosing to send a player to the free throw line, we want to choose someone with high levels of consistency. That means we're down to players 1 and 2. Player 1 has the smallest standard deviation, so the majority of their percentages are closely clustered to the average. Also, their range and IQR are lower than player 2's, indicating more consistency in their free throw percentages over the last 10 games. This makes player 1 the easy choice to send to the line because they are the most consistent based on a closer look at their data. Hopefully today's lesson has shown you that when we are interpreting data, it's important to consider more than just the mean or median values, since those will not always show you the whole picture. As we continue to practice our data analysis skills, we'll learn how all of these statistical measures work together to paint a comprehensive picture of the data, which can help us make informed conclusions. Today, we looked at measures of dispersion, which are values that describe the spread or variability of a data set. The 3 measures of dispersion we looked at are range, interquartile range, and standard deviation. Each of these values tells us how datasets are clustered, or not, around other statistical measures, like mean and median. Be sure to finish up these guided notes and lesson activities before moving on to the online practice. See you next time.